Hi and welcome to Axiom Chemistry. In this video, we're going to talk about particles. And we're going to start by thinking about a fairly large and probably familiar particle, the coffee bean. Now, if I were to take some of these coffee beans and grind them up, I could make a coarse powder, something like this. And if I were to taste some of this coarse powder, and also taste a couple of these coffee beans, well, they would taste almost the same. And that's, of course, they're made of the same stuff. It's just that the particles of coffee here on the right are much smaller than the particles of coffee here on the left. And then if I were to take some very finely ground coffee and make a cup of coffee and drink it, well, at the bottom of that cup, I'd be left with a dark brown sludge, something like what you can see here. And if I were to taste that brown sludge, well, it would taste pretty much the same as this coarse powder and these coffee beans. And that's, of course, because it's also made of coffee. But just the particles in that sludge would be much, much smaller than the particles either here or over here. Now, your tongue might not be able to feel those individual particles, and you might not be able to see them either, but they are still there. And all of that points to the fact that all materials are made of particles, whether or not we can see or feel them. Let's take a look at another example. Let's think about putting some sugar into that coffee. Here you can see 2 cubes of sugar, and if I put them into the coffee, well, quite soon I wouldn't be able to see them. And that's because it will have dissolved. But if I were to taste the coffee, well, I'd be able to taste the sweetness. I would know that the sugar was still there. And that's because sugar, like all the materials around you, is made of tiny, tiny particles. And when I put these 2 cubes of sugar into the coffee, well, they break apart. They dissolve. Those tiny particles break apart from each other. And they're now so small that we can't see them anymore. But it doesn't mean that they're not there. And that leads us back to what is probably the most fundamental concept that you will ever learn in chemistry, and that is simply that all materials are made of particles. Of course, sugar dissolving in coffee is not the only everyday example of this. Think about this little girl here. She's busy blowing up a balloon, but the air that she's putting into that balloon won't all stay there. It will gradually leak out and the balloon will deflate. And that's because the air that she's blowing in is made of particles which are small enough to be able to escape through even the tiniest of holes. What about this little boy who's enjoying jumping in a puddle? Will the water still be there for him to play in tomorrow? Well, that depends. But you certainly can't guarantee that it will be there because if the weather is warm enough and it doesn't rain again, the tiny particles which make up that puddle will gradually leave, shrinking the pool, and eventually it will all be gone. But note that the water doesn't all leave at once. It leaves bit by bit, and that's because it's made of many, many tiny little particles. Have you ever wondered about scents? Why can you smell a flower when it's not even touching your face? And why do people spend money on air fresheners and perfumes? Well, tiny particles from the flower, or from the bought scent, travel through the air to your nose. You can't see these particles, but you know they're there. Without them, you wouldn't be able to smell anything. And of course, it's the same idea when you're cooking. Tiny particles which are much too small to see, travel from the food that's being cooked to your nose. That's why you can smell it. So, as you can see, sugar dissolved in coffee is not the only evidence that we've got that materials are all made of tiny particles. Now, later in this module, we're going to be thinking about an experiment which investigates particles by exploring salt dissolved in water. But before we do that, we should define a few terms. So first of all, a solute. A solute is simply a substance which dissolves. So in that last photo, it was the sugar. Next, we come to a solvent, which is a liquid in which a solute dissolves. And then a solution, which is a mixture of a solvent and a dissolved solute. Let me give you a simple example. Let me just sketch a beaker. There it is. And I'm going to fill it with water. There we are. Then I'm going to sprinkle some salt into that beaker. Now, I've told you that a solute is a substance which dissolves. In this example, it's the salt which dissolves, so the salt is the solute. I've also told you that a solvent is a liquid in which a solute dissolves, so clearly in this example, that's the water. So again, let me mark that. What about the solution? Well, the solution, as I've said, is a mixture of a solvent and a dissolved solute. So in this example, that is simply the salty water. So the salt dissolves, so it's the solute. The water is the liquid in which the solute dissolves, so it's the solvent. And then the mixture of the solvent and dissolved solute, the salty water in this example, is the solution. Okay, I want to give you one more definition, and that is of a saturated solution. A saturated solution is a solution in which no more solute can dissolve. So if I kept just putting more and more and more salt in here, well, eventually it wouldn't dissolve anymore, and I'd be seeing crystals of salt just drifting to the bottom of the beaker down here. And at that point, when the salt was not dissolving anymore, I would know that that water and the salt had become a saturated solution because no more of the salt could dissolve in it. Let's think a little bit more about saturated solutions. You can see here a picture of a beaker. That beaker's got about half a litre of water in it. I'm not going to change the amount of water, that's the solvent, but I am going to add a solute. And the solute I'm going to add is copper sulfate. It's a blue crystal. And as I add it, you'll see that this water becomes more and more blue. And you'll be able to see how much I've put in by looking at this dial. This will go up as the amount of copper sulfate in the water goes up. So let me do that now. I'm going to start adding that copper sulfate. You can see the water is going more and more blue. And eventually we'll get to the point where no more of the solute can dissolve. There we are. You can see little crystals just starting to form or to be seen at the bottom of the beaker. So even if I added more and more and more copper sulfate, no more of it would actually dissolve in the water. The water has been saturated. It's got as much copper sulfate dissolved in it as it can possibly take. And therefore the rest of that copper sulfate just drifts to the bottom of the beaker and can be seen as those blue crystals. So there we are. That's a saturated solution. I do want to just mention one more thing before I end this video, and that's that a particular substance can contain many different types of particles. So let's just go back to our coffee beans here. Each one of these coffee beans is actually made up of millions and millions of other particles. And throughout Axiom Chemistry, we're actually going to be exploring many, many different particles and how they react with each other. But for now, here is a summary of what we've discussed in this video. We've seen first that all materials are made of particles. We've also seen that a solute is a substance which dissolves, a solvent is a liquid in which a solute dissolves, and they make a solution because that's a mixture of a solvent and a dissolved solute. And then we also saw that a saturated solution is a solution in which no more solute can dissolve. Now, if you haven't written any of this down yet, I suggest you pause the video and do that now. Well done, and see you in the next video.